Hello, everyone. I feel like I should have a special tea cam set up. Just a little separate live stream. Just focuses on the tea. Now I have to figure out how to do that now. Let me just get my microphone in place. There we go. Ooh, 26 viewers. Excellent. Everyone loves coming out on a Friday afternoon. Everyone can hear me, right? Oh, good. Good. Always got to make sure the stream works. Okay, first things first. Important. Oh, that's things. Let's look at this week's voting. Yeah, it is a bit more saturated. I was playing around with the color settings on it. I don't know if it's landed on anything useful, but at least it's fun. Super vivid. Okay, so as mentioned in things, this week's options were Sydney breakfast, Japanese sencha, chocolate chai oolong, which were there before, but I brought in from home. Oh, matcha. Brought in from home the Russian Caravan, Melbourne breakfast, and the Earl Grey. What do we got? So most votes for Russian Caravan, and then equal bit of spread on pretty much all the others there. Huh? Big reveal. So this week, it's a black tea. And you're indeed correct, it's Russian Caravan. So well done. I think that's the first correct guess. Okay, so looks like the stream is working at least as well as it usually does. And let me just hit record and we'll begin actually talking about stuff. Streaming, recording, there we go. Okay, so welcome everyone to Programming Fundamentals Week 7 lecture. So more than halfway through the subject now. We should be up to the point. So if you're keeping up with the lectures, you should be up to the point of grappling with objects and classes. And this week I want to talk a bit more about that. Partly to introduce, well, technically some things that you've seen already, but to talk a bit more about them in a little bit more detail. And then also to sort of reinforce some of the things, just so you've seen it a few times and we go over it. The camera might be on a slightly different angle. I can move it over a bit. Because I move it around a lot, so it ends up in strange places all the time. And it's a super cheap webcam, so it gets like a fisheye thing. Whatnot. Okay, so let's create a little class. What do I want to create this week? So let's imagine that we're writing a piece of software that's going to manage a digital, well, not necessarily a digital library, but a library of some kind. We want entries for books, maybe entries for authors, all kinds of things like that. Right? So in our system, like if we were going to build this for real, we'd probably want, some sort of cataloging thing, a bunch of IDs, all kinds of stuff to keep track of things in a database and whatnot. But because we're keeping it simple, we're going to just start with the book, and we want to represent the idea of a book in the system. So if we have a discrete whole concept that we want to represent in an object-oriented system, the way we do that is we create a class for it. That is kind of the whole point of classes, and hence being able to create objects from them. Because we have lots of books, and all books look the same within certain parameters, so the book class tells us what looks the same about all books, and each object then gives the details of a particular book. So when we're designing a class like this, we then think, okay, well, what is it about a book that is useful in our system? And how do we represent that? So a book is going to have things like an author, a title, an ISBN if it's published, number of pages, format if we want to refer to a particular physical book, a variety of different things. So let's just pick a couple of those and put those in. So the book is going to have a title. It's going to have an author. It's also going to have, let's say, a publisher. And just for variety, we're going to have a number of pages. So these pieces of data represent what it means to be a book object. So when I give these things specific values, I get a specific book. So we create an object with those values, and that represents that specific book. Of course, we can have properties that belong to all books. So if it belonged to all books, we'd make it static. And in terms of use, that is the difference between static and non-static things. Static things are properties or methods that belong to the class as a whole. If we think of methods as behavior, it makes explaining this a bit easier. Static things are either properties or behavior that belong to the class as a whole, and non-static things are properties or behavior that belong to individual books or require information about individual books to enact that behavior. Okay. So we want to be able to retrieve a bunch of this information. So we want to be able to get the title. I apparently can't spell author. Little side note there, did anyone watch what was happening there? So you may not see it if you're in the, I don't know if you see the autocomplete if you're in the workspace, but if you're watching the video, I don't have a method called getNumPages, but this was, that's not going to do it now, is it? Assuming the autocomplete is keeping up with what you're typing, it's actually clever enough to look at the properties you've got, the variables, and suggest method names. So I started typing getNumPages and went, hey, I know what you're doing. I've never seen that before. It's probably a new feature in Ed. So, locally installed IDEs often do that. First time I've seen it here. Okay, so we've got a very, very basic class. which stores some data, and we're able to access that data. And then we kind of think about what we're doing, and we say, well, this data should sort of be, once you create a book, it's not going to change its title, it's not going to change its author, it's not going to change its publisher, it's not going to change its number of pages. So within the software system that you're building this in, and you can abstract this idea to building any class, you want to set up your data members, so your class object level variables, to only be able to change if the thing they represent is a thing that should be able to change. Hopefully that makes a reasonable amount of sense. So the title of this book shouldn't change. Okay. So there's two things we do to try to kind of control the behavior of data in a object-oriented system. So one of them is to make things private. So this doesn't stop it being changed per se, but it does stop things outside of this class from changing it. So this allows us to control access to this data, because now the only way to get to this from outside of the class is through a method. Oh, Nick got a screenshot of the thing. Cool. So Nick, who I'm pretty sure I've mentioned this before, former tutor of, I think he tutored this subject as well, and Programming 1, managed to grab a screenshot of the auto completion there, if you go and look at the question thread. So then, if we, like I said, if we make this private, the only way we can get to these is through the methods. So anything outside the class can't change it, which means if it's going through that method, we can validate it in whatever way we feel like is useful. So it may be that, you know, we don't really care. We allow them to set anything we want, and we could perhaps make these public if we want that to be possible. But if we want to do a sanity check on it, so here's a method that we shouldn't have, but it'll give the idea. If I wanted a thing where I set the number of pages, so somehow I change the number of pages in the book, I want to set it to the new page count, then I can do things like if new page count is greater than 0, then do it. Okay. So by mediating access to our data member num pages through this method set num pages, I can impose restrictions on things. I can say, well, you can try and pass in any old nonsense you want, but I'm going to only let it happen if it's sensible, or if it fits a certain format, or, you know, if it's, you know, the moon is in the right phase, or whatever condition it is that makes sense for that particular piece of data within the system. So privacy, well, our access settings, public, private, and there's two others, protected and package protected, allow us varying levels of controls over that. So public is anything can see it, private is only things of this class can see it. But we can go one step further. So the title and the author and the publisher and the number of pages of a book is not just something that we need to control access to, it's something that's actually never going to change. Unless some weird legal battle happens, I suppose a publisher could change, and probably a title can change, but an author's not going to change. So let's do that. Hey, look there. Yeah, as Nick pointed out in the chat, this is actually suggesting all sorts of sensible things here. It's exactly the method I want. So someone can try and set the title, and as long as it is a valid string, then I'm going to set that. Oh, as long as it's a string that contains something. So I could do other checks. I could check that it's actually printable characters and stuff like that, but that's not particularly interesting to watch in the lecture, just to hear about. So I won't bother. Doing anything fancy here. But the author is not going to change at all. So the way that we can get Java to do that is say that a data member is final. So what final means is once you give it a value for the first time, you can't change it after that. And in fact, that's why it's complaining here, because it's saying the blank final field may not have been initialized. So these effectively have to be initialized with some value, and once they've been initialized, they can't be changed later. For more complicated data structures, there's certain complications in that matter. So you can change the content of a final list or a final array, but you can't change the array itself. So that leads us to, hopefully, our next question. If we can't change this value and we need to set it somewhere, how do we do it? And in fact, so for title and publisher, I've got a set method. For num pages, I haven't, because I feel like that shouldn't change for some reason. So I'm going to make that one final as well. I haven't got a way to actually give these two things values, but they need values. If it's going to be a valid book, then probably it should have a title, it should have an author, it should have a publisher, and it should have a number of pages. And it should have them as soon as it exists. So we could, in principle, have set methods for everything and keep some kind of counter for the final ones that say, well, if you've already set this once, then I'm not going to let you do it again, even though you'll try and call the set method, and then you'll wonder what the hell's going on, because it's sort of weird to have a set method that you can only use once. Not completely unheard of. You can program badly in any programming language. Just paraphrasing, you can write Fortran in any programming language. But yeah, so I want some way of setting these values at the time that I make the actual object. And that's exactly what a constructor is for. So constructors we've seen before. No, that's not the one I wanted. I want... Just realized I forgot to make the class public. And in fact, we've been using constructors all the way through the subject. And I've mentioned them, of course, but we haven't really talked too much about them. Ew, Scabber. So every time we've seen this line, we've been seeing a constructor in action. So this thing here, this method call, is a constructor. And there's a little bit of language structure here. Anytime you use the new keyword, it has to be followed by a constructor of some kind. So arrays have a special constructor, just to be annoying and have non-standard syntax. But everything else that you can use with the new keyword has a constructor that looks syntactically like this. Obviously, they're not all called scanner and they don't all take a single parameter, which is an input stream, but they are always the name of a class and a list of parameters. Oops. And this is in fact the only time you can run a constructor. So if you call a constructor in Java, it has to be preceded by the new keyword. And the new keyword is the thing that tells Java that you want to create an object of whatever thing you're giving it over here. So Java sees the new keyword and says, all right, I'm going to go into memory allocation mode. What's the thing you want me to allocate some memory for? Looks just to its right, and you get a class name. So it knows, because Java requires you to call the constructor the same thing as the class, it knows that it has to allocate enough memory to fit one of these in it, whatever that might be. And also where to find this constructor. Other than that, beyond that point, the constructor works like a normal method. So it has a list of parameters and you have to give it values that have the same type as those parameters, and then the constructor does whatever it does. So normally the constructor initializes the values of the object. So the whole point of the constructor, and hence the name constructor, is to be run at the time of construction of the object and construct it so that it is usable. So these final variables, and probably anything else, in fact, even if they're not final, must, or at least should be initialized in the constructor. What did I call this class? Book. So a possible constructor for the class book has to be called book. It doesn't have to be public, but if you want other classes to be able to use it, it has to be public. And it should take in appropriate pieces of information to completely construct the object. So what we have here is a fairly standard, straightforward constructor that takes in a parameter corresponding to each internal data member. So we've got one for title, one for author, one for publisher, and one for the number of pages, and sets up those data members with those values. So because this is run at the time of construction of the object, there is no reasonable point in the execution of the program where book would not have some value for each of these things. So technically you could argue, okay, there's a point in time where it doesn't have those, because Java has just allocated the memory but hasn't copied the values over. But there is no programming point in time. There is no way to insert a line of code in between the creation of the object and the initialization of those variables if they're in the constructor. Okay, so before running the constructor, the object doesn't exist at all, and after running the constructor, the object exists and the code in the constructor has run. All right, so you can't, once this starts, you can't do anything until it's done. So, in a certain sense, that's kind of all there is to constructors. That's what they do. They're things that run at the initialization of an object to create a new one. They don't have to just set variables here. You can write basically any code you want. You can call constructors as superclasses when we get to inheritance and stuff like that, or when you get to inheritance. You don't have to give it one parameter for each data member. There might be some data members that have sort of sensible natural values that you can fill in. So for example, well, I'll give you an example in a moment. But the key point of the constructor is that it runs at the initialization time. Like the act of building an object in Java is the same as running a constructor. So I've got a question, the constructor has to have the same name as the class. Yes, that is a very strict rule. There's no way to make a constructor that does not have exactly the same name as the class. And there is also no way to make another method which also has the same name as the class. So when you try and compile it, if it's got the same name as the class, Java thinks that you're trying to make a constructor. So it has to look like a constructor. So one notable difference between the constructor and another method is that it doesn't have a return type here. So I don't have to say that it returns void. So in fact, you can see the linter complains immediately. So you can see the error. This method has a constructor name. So it says this thing looks like a constructor. It doesn't tell you what is wrong with it, but it thinks, okay, you're trying to write a method, but you've given it the wrong name. And it's not just void, it's anything. Okay. Because a constructor does not, well, I was about to say it doesn't return something, but it does. It does return something specific, but you don't have any choice over what it is, so Java doesn't let you mess it up by putting anything there. So what it does return is basically represented by the object toString method. Oh wow. Let me sorry, let me just force something here. Oh, that's not going to work because it's got dynamic dispatch. What's something that looks ugly but yeah, okay, so I'll use an array. So here, okay, so an array constructor looks a bit different because arrays are jerks and are kind of halfway between primitive types and halfway between objects. They are technically an object, but they have special syntax and they do certain things slightly weirdly that you don't need to worry about, but nonetheless, they're not quite right. So the thing that the constructor returns is effectively represented by this garbage here. So this little bit here says that it's an array of ints, and this thing here is the default hash code, which is based on the memory address of the object. So the thing that the constructor is returning is the location in Java's memory map of that object that you've just created, which is exactly what the value of an object an object variable is. So diverting into the details a little bit here, if you remember from last week-ish, we had our stack, and I'm going to create a variable called b, which has type book, example, and the value of this object variable is a reference to the location in memory where the actual data is stored. Whatever it is. So the thing that a constructor returns is this value, whatever it is. So if this address is, OX1, whatever it is, however you want to represent your memory location, the value of a reference variable is that address. And that's what a constructor returns, and you can't change it, so it has no return type. So you can simply remember that as constructors have no return type, but if you want to understand it a bit better, you can remember that reference variables don't store the data directly, they store a reference to the place the data is in the heap, and the thing the constructor returns is that place, that value, that memory address. Yeah, so just answering a thing from the chat, the whole idea of the constructor then is to set up the initial values of everything you need to set up in the object, or do any other setup tasks that are required. So maybe it's not setting up a value, maybe it's actually running a piece of code. So you might want to, one of the things you might want to do in setting it up is log something in a log file. So you might, do log. So I'm just making this up, this is not going to work at all. So this line, apart from not working because I just made up some nonsense, is a thing, an example of a thing you might do at construction time. Oh. I haven't done that yet, have I? So your base task in a constructor is setting up the values, but it's also doing anything that needs to happen at the beginning. That's the wrong place. Sorry. Just before anyone gets too confused, I just gave Nick access so he can hopefully do useful things in the background so I can keep talking and he'll help build up the examples. As he said, he's doing useful things. Just put that down a little there. So, So again, that's sort of all there is to constructors. So what else can we do with them? Like, this is kind of like, okay, we've got these variables and we assign them, and maybe we should do some other stuff. Woohoo! Well, there's nothing that says we have to have a single constructor. We can quite happily have multiple constructors the same way that we can have multiple methods with the same name. So for example, say our database represented not just published books, but books that are about to be published. It might have things that are only sort of accepted for publication but haven't yet actually hit the shelves or something like that. So maybe all we know is the string is the title and the author. And maybe the publication date. So then we can choose when we're creating a book to give it that information, and it'll call this constructor instead. This is nice, I don't have to type. And that information gets filled out. And then you might say, well, why am I in it? Because I don't want to introduce the date class because it's awful. Yes, Nick does make a good point. Do not use ints to store dates. There is a proper date mechanism in Java. It's just not worth getting into now. Yeah, don't use it to do money either. Just getting handy advice from Nick in the background. So the other thing we can do, so we might say, well, we know if it's an as yet unpublished book, we know the title and the author, and we can choose, if we still want to initialize something like publisher, to have a fixed string that says, something like not yet published. And maybe 0 pages or something like that. So we can set up values which have, in certain conditions, fixed set up the variables which in certain conditions have fixed values by creating a constructor for that situation. And you can create effectively as many constructors as you find useful for a particular class. So there's not a lot of other interesting ones we can do in this particular case. But, we've got a couple here, and you can see how in other classes it might be interesting to do things in slightly different ways. So what else can we do with the constructor? So you can see in both of these, I'm setting the title and the author and the publisher and the number of pages. And I should probably be setting the publication date in this one as well. Not publication date. Okay. But this kind of goes a bit against our hope at the moment. What should be our budding intuition that if you have the same code twice, you're repeating yourself, and you shouldn't be. You should be doing it in one spot and reusing that code. Ooh, he's created a logger. So we can quite happily do that with constructors. So we can call one constructor from another. And in general, we can call methods from a constructor. There's no problem with that at all. So just repeating that one I did just before. I can use the this keyword in its second slightly different role. So this also allows us to call other constructors in the same class. So instead of repeating the code here, I'm taking this information, passing it through to this constructor, and filling in the blanks with the sort of the predetermined values. Notice now that Nick has added this logger code, this also allows the logging to be done in so this is just an example of what can be done. But anything that you want to do at construction time allows it to be done in a consistent single way. Right? So I don't have to repeat this in this constructor. All my other constructors are just assembling the data in the right pattern and passing it to a sort of like a central constructor that does all the actual work. Yeah. So the only trade-off there is if you're going to call another constructor, it has to be the first thing you do in the constructor. And so you can't do something else and then call another constructor. You have to call it first. So is the logger actually functional yet, Nick? So I just wanted to check before I compile and get a weird error that derails us. Okay, so well, I guess we'll see if we can compile that, see what happens. It doesn't recognize the logger yet. Okay, hang on, I'm just going to comment this out for yeah. Hold that out for a moment. So let's just compile that. Wait, what? Oh, there. So it all compiles fine. So as it is, I've got a constructor calling another one. So if I try and do something here, I mean, the linter should probably pick this up. Give it a moment to think. I'll run the compiler while it's there. So you can see call to this, i.e. the constructor, must be the first statement in the constructor. So I can't do this after I've done something else. It's a requirement that if you're going to call another constructor, it is the first thing that you have to do. But I can quite happily do it down here. As Nick has noted in the comment, I can quite happily do it down here. Everything's fine there. So, what happens when we want to create a book? Well, at that point, it now looks exactly like all the other constructors we've seen. We just pass it different information. So let's pick a book. Too many choices. What's it nice? So let's pick, we're going to add Fundamental Algorithms by Donald Knuth. The publisher is Addison Wesley, at least in the ancient edition I have of it. It was published in 1975, and it has last numbered page 634. Oh, Nick's working on stuff there. But this is exactly how you use a constructor. Right? And this should be no surprise. This is exactly the same format that we've been seeing throughout the semester up to here, particularly with Scanner, but it's basically the same one as with arrays. It's the same thing that we're seeing in the week 7 and 8 labs when you're creating objects of the bank account and whatnot. And all it is saying I'm creating a variable B of type book. So this B is going to reference, let's go back to our drawing here. This B is going to reference a piece of memory in the heap that is compatible with type book. It calls the constructor. The constructor creates this thing over here, which also has type book in this particular case, and it has whatever data that we've put in there. So let's so Fundamental Algorithms by Knuth, Addison Wesley, and 1975, and I'll stop there because I don't need to make it messy, just to make it useful. And this bit here, just here, that call to the constructor is the thing that creates that thing. So the line new book, book, blah, 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 creates and initializes that thing. and then sets our variable b to reference it. So that's what this line in total does. It creates this piece of memory over on the stack, which is the variable itself. It sets up this piece of memory on the heap. It initializes those values in that piece of memory. If you're really getting this, you'll realize that in fact those values that it's setting up in here are other object variables. So in fact it's actually setting up a variable which points to another piece of memory which contains that data. So it's kind of cascading all the objects all the way down until you get to primitive types. But for the purposes of understanding this, all we really care about is that this book object contains that information. It holds references to that information. Yeah, so the B book bit creates that. The book constructor sets up this thing, and new actually allocates the piece of memory and returns the address to that variable to set it all up. So that one line sets up all of that. But then why is this interesting? Why do we not just have some variables with this data in it? So the useful part is that now that we've got this class that we can construct, because we've got a constructor, we can make many books. And all of these books structurally look the same, but contain different data. Now I have to get another book. I'll do this one quicker. He lies directly to camera. Oh, that's not bad. I'm a little worried about what Nick's typing here. I take no responsibility for the books that Nick is recommending. They may be good, they may be bad, who knows. Ah, there you go. So now we can have here 3 books, which are all, in terms of the program, structurally the same. Sorry, I forgot what the variable names were, B1, B2 and B3. The 3 bananas. B1, B2, which is also a book, and it references a different piece of memory, but one that looks basically similar to the other ones. was in there. I don't actually remember it. Okay. So again, it's like, oh yay, so we can have a bunch of books. What are we going to do with them? Well, what did we do when we had a bunch of int variables? We can start collecting these all together. So between having a class and being able to actually build the class, we can start treating things the same. I'm not sure what Nick's doing down there. Hey, there we go. So I can create an array of books now. So I can have a very small library of 3 books. So we can treat them now as pieces of data that have the same basic structure, which means we can collect them together and we can do things. So we can use that same for each loop. And every time we get something out of it, we know it has a book. And we know we can print it like a book. So let's set it up so that we can actually print a book. So we've seen this one briefly. Whoa, wait, was it in Prog 1 or this one? Well, hopefully we've seen this before, but maybe not. No, we did see it before because I went off and told you about object. Every class in Java has a toString method. Okay. So it inherits one from a parent class called object no matter what. So it always have one to begin with. But what we can do is override that one and have a more specific way, a way that is appropriate to books for printing out what they look like. So when you print it, it says, something more interesting than just giving. So while Nick's working on that one. So if you don't override the toString method, where did it go? No, I've lost it. If you don't override the toString method, you get that. Oh, there it is. I saw it. Yeah, if you don't override the toString method, it just prints out something like this. Basically, it prints out the type and then a representation of not quite the memory address, but something that is close enough to it. Technically, it's the hash value, like I said. But if we don't want to do that, we can do something like what Nick is setting up here. We can set up something that gives us back a string. So ultimately, this is just a method. It just happens to have a particular name called toString, and it returns a string. It can set up a nice method that returns a string that's going to print out something that looks pretty reasonable for a book. So I'll give Nick a moment to finish that before I actually run the code. But the fact that we've created this class means that we can do things like this. Our book class now represents a certain type of data and a certain set of behaviors for interacting with that data, including, for example, the toString method. But to be able to create that class, or sorry, to be able to create objects of that class, we need constructors. So our constructors are like our first port of call. So when we're creating these things, we go, okay, what data is it going to store? If it's going to store that data, I need a way of getting that information in, and the constructor is how you do it. So while Nick's doing that, I'll check the chat for questions and stuff. Books about tea. I do need some more books about tea. It is mostly programming and maths books. There are a couple of non-programming ones. Anyone who's keen can come and have a look. No, I don't have any kids, actually. Alright, so there's a question there from a couple of people talking about the array. It's basically asking what's going on here. Does it reference the class books? And yes, effectively it does, the same way that this does. So there's no class int, but you remember when you create an int array, these two things here, the open and close square brackets, are the thing that tell it that it's an array. It's not this whole thing. What this whole thing does is tell it that it is an array with those two bits, and then what underlying type that array is going to store. So if I, with this line here, oh, yeah, Nick is ready for the next bit. So if I have book array whatever somewhere over in memory, well, let's give it a name. So on the stack, it has a variable called books, and it has type array of books, or array of book, and it references a piece of memory over here. So this actually also has a length, which in our particular case happens to be 3. So number 0 has type book, number 1 has type book, and number 2 has type book, and these reference, not necessarily next to each other now, but somewhere, a book with the actual data in it, and another book with the actual data in it, and another book with the actual data in it. So if we did this, then we have a similar thing in A. So we have a thing called A, which has whatever length it has, and it references a piece of memory over here, which is however many int variables, which have whatever values they have. So the only difference between this, don't know how I did that. The only difference between this and this is the underlying type of the array. So this bit here gives these things, the types of the elements of the array. Yeah, so int is an array of ints, but so int square open close square bracket is an array of ints. Book open close square bracket is an array of book objects. Yeah, or to put it another way, book is the type of the elements. This is exactly as you've written in chat. Book is the type of the elements, and book open close square brackets is the type of the array. And we can do this with any class. So it doesn't matter here that it's book, that just happens to be the thing that we want to store. So I think Nick said it's ready. So let me make this quite large. All compiles. We're going to run the runner. Oh, well, it doesn't matter how large I make it, it only fills up that much of the screen. So you can see I'm just going through. I've got the 3 outputs from the constructor. So you can see the constructor is saying, hey, I've made this thing. And when I print it out, the book object now allows us to say, when you print me out, I'm going to look like this. So it's printing out, I'm a book with an open parenthesis and then a bunch of details about the book. And each book prints out in exactly the same way, but filling in the data that is local to that object. So each of them is using that same structure because that's defined by the book class, but it's using its own data. And therein lies the important part about object-oriented programming. That class, at least class-based object-oriented programming, classes give us templates for objects, and objects allow us to carry around data along with the methods that allow us to manipulate or access that data. What's /t and /n? So /t is the tab character. So that's what basically what Nick's used to indent this in one tab, whatever the printing thing thinks the tab is. And /n is the new line character. So that's the thing that makes this print over multiple lines. So you can see he's ended each of them with a print book, colon, space, open brace, and then go to a new line. Then print a tab, print title, colon, space, print the contents of the variable title, so this thing all the way up here. Then print a comma, and then go to a new line. So that /n is the thing that's the difference between print and println. So print prints whatever you give it as the parameter, println prints whatever you give it as the parameter, then automatically sticks a /n on the end. So it sticks a new line character. That's rather dark now. Smoky. How are we going for time? Another 20 minutes. Good. Okay. So now we have, hopefully, a slowly growing idea of what a class is, what an object is, and how they work together. That a class gives you kind of your definition and a place to put things that are universal for all things of that type. And an object is a particular instance of that type. So talking about it in an abstract sense, a book is a physical book is a thing with a title and an author and is a collection of pages bound together in some cover. And these things behind me are particular instances of books. That is, the things that are actually books, not including the T and the pictures and stuff. So in some sense, the book class is the thing that defines what they all, the common things that they all look like, and the book object is each individual book. It's not a perfect analogy, and there's a it is thankfully mostly dropped out of the folklore that any class you create should represent something real. That's a really bad way of phrasing it. So when you're programming, what a class does is represent any single coherent idea of something that should be together in one spot. So a lot of things in the real world have a ready analogy for that because they are already obviously single coherent things. But when you're programming, you get to make the choice about what it means to be a single coherent thing. What is the information that you want to pass around together as one unit, basically, is a better way of thinking of it. What about entity? Let's not go there. Type serves that's yep, okay, that's good. So just checking the questions to make sure we're not missing anything. So this question is that like declaring a variable in one class and can be used by other classes without going to define in each and every class. Yes, if I understand what you're saying there. So this sort of gives you. So there's a number of I think there's a number of examples of what you're talking about, but I'll just grab the nearest one. So when I'm defining these in a class, that means when I create this book over here, or this book here, or this book here, or this book here, it automatically creates individual instances of those variables with this data set up. Can there be constructor overloading? Yes, absolutely. What does the default constructor do? So that was the next one I was going to. So in creating these classes, you may have noticed them before. Like, we haven't really been doing this, but you have kind of created a class here and there. So what happens if you don't create a constructor? So this is not a particularly useful thing to do with a class. It's going to make Nick sad. Oh, he's already made one. Oh, is that what thingy is? Okay. Yeah, there we go. So we have a thingy that has no constructor. So I'll just delete simple. So it can still quite happily have data. It can still quite happily have methods. Let's give it the. Let's comment those out for the moment. Build this up again. Oops. Oh, it's in the room there. So if you look at the new books down here, I'm calling a constructor, and hopefully it kind of makes sense. It's calling this, this constructor or this constructor or whichever it is. But what's going on here? So I don't have a constructor. But obviously this thingy is being created, because I've got this object lowercase thingy which has this value in it. I'm able to call the toString method because it's printing out here and it's keeping that value, so something's happening. So what's going on? I just said we need to call a constructor when we create an object. So one thing Java does is, if you define no constructors at all, so as soon as you define one, you don't get this. It says, well, you've defined one, so I'm not going to fill in the blanks for you. It defines what's called a default constructor. So all a default constructor does is set up the memory. I mean, strictly speaking, it doesn't really do anything at all. But it allows you to write this line here, because this is absolutely necessary for creating an object, without actually doing anything. So it doesn't initialize any of the data in here. It doesn't do anything, any other setup. It doesn't do anything else. And as Nick has just written it, it looks just like, effectively as if you'd written a constructor that looks like this. Public thingy, open and close parenthesis, so no parameters, no code. Oh yeah, we'll call the default constructor of the superclass as well, but we don't know what a superclass is, so don't worry about that at the moment. Right. So Java will quite happily let you create classes without constructors. Well, without visible constructors. It absolutely needs them, because that is the only way you can actually create an object in Java. It has to call a constructor. So if you've got a class where you don't know the values of the data at construction time, and there's no actions that you need to take, you can just kind of go, well, hey, I'll just let it use the default constructor. But if you don't, and you don't define a constructor, you're going to end up with an object that is probably in a bad state. Because if I had a default constructor for book, I'd have a book that didn't have a title, didn't have an author, didn't have a publisher, didn't have a number of pages, and didn't have a publication date. And even worse, 2 of these are final, so it would be completely invalid. So I've got things that have to be initialized, but haven't yet been initialized. So I can sort of forcibly insert a default constructor in there. But you can see it'll complain. Once you start having data that needs values, it says, hey, you can't do that. You need to actually put some effort in here. Because it has final fields. Okay. Alright, where are we up to? Got 10 minutes. I think actually... Yeah, so we've got 10 minutes left, so I don't think I want to introduce anything new at this point. So I'll just check for some questions, and maybe we can get an early mark, especially as everyone seems hungry. think, yeah, Bitto has made everyone hungry, including me. I mean, I can't eat during the stream, but you guys can, so feel free to take food into the lecture. You know, if you drop it on your own floor, that's alright. Okay, I'll just do... yeah, you may want to check out the workspace later on after Nick has finished meddling with it. What are we? That's good. That's good. Yeah, there's nothing. So there's a question, what does final do? So far it hasn't made any difference. Is it so that in the future you can change the publisher's name without changing it? Yeah. So, so for example, I can in principle change the publisher. So in fact, somewhere down here is a set publisher method where I can alter it. If this is final for author, I can't change that at all once it's done. So I can't reassign a book to a different author, a particular book to a different author. So this has other uses, but we'll talk a bit about those later. How do we differentiate constructors / methods with the same name? So here we've got two constructors with the same apparent name, book, but the way that Java or the Java compiler and the JVM looks at it is that this whole thing is the name. So it's not just what we think of as the name here, it is the name plus the list of parameters and their types. So as far as Java is concerned, things have different names if either the thing that we call the name is different, or it has the same name but a different number of parameters, or it has the same name, the same number of parameters, but the types of those parameters are different in at least one spot. Yeah. So the full name of this one here, as Nick has written, is book string string int. The full name of this one is book string 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 int int. So that's how it differentiates it. And that's exactly the same for all methods, constructors or otherwise. So I don't have an obvious example here, but you know, you could make another set title method, and as long as it didn't just have a single string as its only parameter, Java can tell it apart. Can you just rearrange the inputs for that? Yes. So if I had a book int int string string string, it would consider it as a perfectly valid different name. It might be a very confusing thing to have, but it's perfectly possible. What does this dot value do? So this, the keyword this, refers to the current object. So when you're defining the class, you don't have an object to talk about, right? But when you actually run it, so I'm going to uncomment this code here as well. Now I'm here. When you actually run it, you're moving values about. So where is one where I've called it? Yeah, so my first thingy dot data equals 7. So if I'd called a method there, let's print one. Books. Dot. So I'm calling the getAuthor method. So if I go and look at the getAuthor method, I've got return this.author. So the this pointer, because it's actually just a, well, reference I should say, gets the same value as whatever it gets called on here. So in most cases it doesn't change a lot. So these ones here doesn't actually matter, because the only valid understanding of num pages is there at that point is this class level variable num pages. It's a reasonably good programming habit to get in to write this, because it's clear what you mean. Like, so if another programmer comes along and reads this, they know, oh, they mean the class level variable num pages. It does have places where it is definitely useful. So for example, in the constructor, I've got a parameter called title and a class variable called title, because these represent the same information, so it makes sense for them to have the same name. But then if I try and run this line of code, like even the linter picks it up, the JVM goes looking for a variable called title, and the first one it finds is the parameter, because it's the closest one to this piece of code. But that's not what we want to do. We don't want to assign title to itself. We want to assign title to the other one, the other title. So this pointer allows us to differentiate between the two. So this is the real problem of this, because we use this as a normal word. The one on the right hand side refers to the local thing here. The one on the left hand side, because I've prepended it with this, refers to the class level one. Yeah, so what this.title is the actual title variable in the book. Title is the parameter coming in there. Return this and get complementary. Not complementary. I mean, they all just do useful things, I guess. So return gives back a return value. This refers to the current class. Get is just a word that we use to define stuff, basically because of a standard. Yeah, so each object is a new copy of the class with particular data inside it. So it is, not exactly, because this picture is fairly wonky. These three books are all just books, but they have different data inside of them. So one's fundamentals of algorithms, one's effective Java, and the other one is, what did Nick call it? Fire Within, I think. Yeah, the Fire Within, whatever that is. Right. So these are all, in a sense, copies of the class book, but with particular pieces of data put into them. All right, I think we've covered everything there, and we're now right on time. So we almost got an early mark, but I had to go and ask questions. But as far as this lecture is concerned, finishing on time is actually good. Oh, there you go. Children's fantasy novel. That sounds pretty cool, actually. Dragons in the Modern World. I'll have to look it up. Okay, alright, so thank you everyone for the... Oh, we got up to about 60 people. What was the maximum? 62 concurrent viewers. Dropping off. I have to make these more exciting. But thank you all for coming. Have fun in the labs, those who have labs this afternoon. I'll see some of you on Tuesday, some of you next week on Friday, or whenever you feel like contacting me. Yeah. Thanks all. Go have a nice dinner. Have a nice weekend. Yeah, go get something with an explosion maybe, or more cats. Maybe I need a thumbnail with some cats in it. Or exploding cats. No, that's a bad idea. Oh, I forgot to shout out the sponsors. Oh, we're on. Well, they'll have to pay more money next time. Spend 2 hours on the week 7 lab is all right. That's not bad. That's 2 hours spent coding. That's good. So I mean, this week was a Patreon episode, surely. So thanks to all my Patreon sponsors. Now, 2 hours tearing your hair out, that's program. Like, get used to that. Yes, and thank you, Nick, for helping out with that. As usual, very handy. Sadly, I do a lot less programming than I used to. That's the problem with lecturing. You start teaching people about it, and then you go spend all your time writing lessons about it instead of actually doing it. Alright. Looks like everyone's out of questions and everyone's ready for dinner. Once again. Yeah, Nick will trade. He'll write the lessons, I'll write code. Sounds like fun. Yeah, alright. We'll end the stream there and see you all soon.